just to get started, let's just take a brief overview of all the trace options that are available in zTPFGI. So first of all, we have the source view trace, and this is, I'm sure you're familiar with, where you can lock a file into source view and then step through the code line by line. And we have the macro instruction trace. This is where you can set trace options and it captures the ECB and shows it in the ECB window. Basic trace options, which I'm sure that everyone or most people listening are already familiar with. You can select which programs to include or exclude, include into or exclude from the trace. And you can also select specific macros or macro groups to stop in, or you can decide that you want to stop in all the macros that are hit. And when you're stepping, you can step through macro by macro, or you can step through instructions as well. And the advanced trace options that we have, which is really the topic of this particular webinar, are the address stop and the trace store. And within the trace store, I'm going to also show you a couple of additional features, which is the compare feature and compare with the mask feature. We also have certain error checks options, which are, I'm not actually going to demo these, so I'll just briefly mention them before we carry on. So the error check options, these are just different settings for being able to check for corruption, and you can check the heap when the ECB execution stops or on enter back, and you can check the block when the ECB execution stops, and you can validate the ECB stack on enter back. And these are simple checkboxes within the trace options that you can check or uncheck to turn them on and off. So now let's just move straight on to the demo, and the first thing that I'm going to demo is the address stops. So just moving to zTPFGI itself, I'll just connect to a system. And I'll just click OK, and we'll just wait a few seconds while we connect. And you can see as soon as I've connected to a system, we have the System tab become available. And here you can see that we have an ALC1 terminal available. If I just click this button, that opens the ALC1 terminal. And as soon as I have the ALC1 terminal visible, I have here the Trace tab in the ribbon menu available. And this has a group of trace options. And you're probably already familiar with the All Programs and Selected Programs, which allows you to select specific programs to include or exclude, or you can just decide to include all programs. And we also have the buttons for controlling the macro trace options, so you can trace all macros, no macros, or you can specify macros or macro groups. Now, this specific demo we're going to be concentrating on is these two buttons, the address stops and the trace store. The other thing to note about this ribbon menu is that whatever your trace options are, those particular buttons are highlighted, so you can see at a glance what you have set. And these exact same buttons are actually also available in the terminal window itself in miniature. So that's just to provide easy access, so you don't, if you're somewhere else in the ribbon menu, you don't have to be coming back to the trace tab every time. Okay, so on with having a look at the address stops. So I'm just going to click on this address stops button. And what this does is this opens the trace options dialog, and you can see that there's different tabs for the different types of trace options. It's one dialog, but it opens it directly at the address stops tab for you. And in order to add an address stop, you just click the add button, and the first thing it does is it asks you what SO you want to stop in, and you can type your value here, or you can drop down and choose one. What this drop down list is just, it remembers previous entries, so as I've entered this SO name before, it's remembered it. So I'll just click OK. And you can see it's added this SO name here, and the member name is a drop-down list, and this one actually automatically populates itself based on the member objects that are within the SO that I've specified. So if I show you, you can see that this particular SO only actually has one member object, so I haven't actually got a choice there. And then I can enter the displacement that I want to stop in. So I can type in hex. So if I put 0x, that's saying I want to enter a hex value. And if I put in, say, 0 hex 84, I could just as easily enter the value as decimal by just excluding the 0x at the beginning. So I could put in 132 there. And if I hit save, you can see that it's been added to a list of address stops. So I've got the SO, the member, and the displacement, which is shown in hex. Even if I enter it here as decimal, it shows it here as hex. So let's go ahead and add another one. And this one I'm going to add is UVA1. And this one actually has two objects. And I'm going to just choose the first one, which is the UVA1 member object, and I'm going to give it a displacement value. And you can see that I now have 2 in my list, and this list can hold a maximum of 8 address stops. So you can actually set, at any one time, you can set 8 address stops. So I'm going to say OK. This will close the trace options dialog. And I have my test command, which runs my test program. So I'm just going to run that. I've just clicked the arrow because I've run it on previous occasions, so it's just remembered it. So I don't need to actually type it in. And so now our ECB has stopped. And if we have a look at this machine line, we can have a look at where we've stopped. And we've stopped in the SO PR80, in the object PR80, and at displacement 84 hex, just as we had asked to do so. So now if I step again, we should just run to completion. Okay, that's how easy it is to add address stops and stop at an address. Next thing I want to show you is how to edit your address stops. So I'm just going to click, it's the equivalent button, but just down here. So I'm just going to click this address stop button to reopen. And to edit an address stop, it's as simple as selecting from the list the address stop that you want to edit and clicking the edit button. And so here you can see that it's loaded the details so that I can edit it. So let's just make a simple change. Let's change the member object to the UBT4 one and click Save. And you can see that now in my address stop list, I'm set to stop at UBT4. Obviously, you saw from my previous run of my test program that my PR80, when I run that test program, it stops in PR80. It doesn't stop in UBA1. So it's not going to stop there anyway, but that's just to show you how to edit. While we're here, let's just, so that we can continue with our demo, let's just add another
Viola, sorry to interrupt. There's a question from David.
That one.
1 second. I've unmuted David. Can you please put your question directly to the presenter and the technical team here, David?
Sure. We've got a lot of activity in our test system, and I want to only want to stop on my entry control block, and I didn't see where you excluded or just included your activity.
Yeah, I don't know the answer to that. Karthik, I don't know if you could step in with that.
Yeah, actually, the control is going to only your programs for your sessions. It's not for the other programmers' entry or programs.
How does that occur? I'm curious because that would be beneficial for our environment.
Okay, you're giving your entry from your terminal, so we are just controlling the through the session. So if you are set up the desktop, that will only handle your particular session, not the complete.
From your terminal. Okay,
yeah.
Understand. I just got it. Just connected. Okay, there's a follow-up question. When you specified displacements, is there boundary concerns? What if you put your stop in the middle of a compare logical character?
It should be boundary conditions. So based on your listing, you should put your addresses, displacements.
So the programmer has to concern themselves with boundaries. You got to put it on the front of the opcode.
Yes, right. The programmer already having the listing, so based on the listing, he needs to put the displacements. He is not supposed to put other boundaries. I mean, the characters. He needs to switch with the correct displacements.
Okay, understood. Thank you.
Thank you.
Thanks, David. Thanks, Karthik.
Okay, well, I'll carry on, and then I guess if there's more questions, we can stop again. Okay, yeah, so I'm just in the midst of just adding another one just so that I can continue with showing the next aspect of the address stops. So I'm just adding a new displacement to stop at, really. And so now I've got two displacements, one at x84 and one at xe8. So I'll just click OK, and I'll just run my test program again, and this time, of course, we're expecting it to stop twice. So we'll just wait a second while we capture the ECB. So now you can see, as expected, we've stopped at displacement 84, and if I step again, we've stopped at displacement E8, and if I step again, we should run to completion again. Okay, so the next thing is to show you how we can delete or disable address stops, and that really is just as simple again. So first of all, deleting, again, you just select the one that you don't want anymore. I had previously added this UVA1 address stop, which is obviously fairly useless for the demo other than to show that how to delete. So let's go ahead and delete this one. I've selected it, and then I just hit the delete button and it's gone. And the other thing to show is that you can actually enable and disable these as well. So enabling and disabling is just as simple as to disable, you uncheck the checkbox, to enable, you check the checkbox. So you just, if I just disable that first one, then I'm sure you can predict that next time I run, we will only stop at the E8 displacement. And there we are, we stopped at the E8 displacement. So that's just showing really how to set and manage address stops. And you can see as well that when an address stop is set, the button for the address stops is down or highlighted so that you can easily see at a glance that you've got an address stop set. Okay, I'll just run that to completion again, and we'll move on to having a look at the trace stores. Okay, there, and what the trace store does is it allows you to specify positions in the data structures where you can set options, trace options, and say the conditions under which you want to stop. Now, as you can see, we still have our address stop set. I'm going to go ahead and set trace store anyway, but later down the line you'll see that this is going to cause a problem, and the problem is that trace stores and address stops are mutually exclusive. You can't have both sets at the same time. But we'll see what happens, and we'll cross that bridge when we come to it. So let me just go ahead and open the trace options at the trace store by clicking on the button. And you can see here that the first thing it asks us is what the trace store type we want to set our condition under. And we have core address, data level, DCP, ECB field, file address, register. They're all quite similar, but let's just quickly take a peek at each of them in turn. So selecting the core address, we can see that it first of all asks us for a parameter, which is the core address, and a displacement, and the watch length, which is how many bytes we want to watch. And we also have this use compare data area, which is one of the advanced options that I had mentioned in the PowerPoint earlier, and we'll come back to. And then just a quick peek at data level, you can see that it's pretty much the same, except that you choose a data level. DECBs, again, similar, but you just enter the DECB name. File address, for this you do actually need to know the address of the file that you're interested in. And as long as you know the address of the file that you're interested in, you can enter that. Apart from that, it's similar. And the register area. Now, and you select your register, and when that changes, we stop. There is a warning that comes along with setting a trace store on the register area, and that there is actually a system overhead with this, because what we're having to do is we're having to actually, for each instruction, we're having to actually check the register to see if it's changed. So this particular option would need to be used with caution because of the system overhead involved. But to continue with this webinar, let's have a look at the ECB field, which I sort of skipped over earlier. And we'll continue to demo using this as an example. And you can see with this that we can select the different ECB field groups. And depending on what we select, this ECB field drop-down will dynamically update itself. So, for example, if I choose EBX switches, you can see that you can choose EBX switches. If I choose, I mean, I could choose any of these and see what it is. So it really depends on what you're interested in. For this demo, I'm going to stick with the EBW area. And I'm going to actually also stick with the beginning of the EBW area. And you can also see that we have this show hide area, which if you're not interested in looking at the details, you can hide it. But this shows a few things about the area that you've chosen, like the displacement in the ECB, the default watch length, and the maximum watch length, the maximum watch length being the size of the EBW area. And then it says, can the displacement be modified? Well, in this instance, no, it can't, which is why we don't have a displacement box for updating. Can the watch length be modified? Yes, it can. So here's our ability to update the watch length. And does the watch area need to stay within the confines of that specific field? And in this instance, no, it doesn't. So what I'm doing here is I'm saying, okay, let's watch the first byte, because I've only set my watch length to 1. So I'm saying let's watch the first byte and stop when that changes. So I'll click OK to keep that, and this is our problem that I had mentioned earlier. So as I said, the trace store and the address stops are mutually exclusive. Therefore, I have a decision to make. Do I want to keep the settings that I've just put in for the trace store and disable my address stops? Or do I want to discard the trace store settings that I'm trying to set and just keep my address stops? Or do I want to return to the dialog box and make some changes myself? Or do I want to just cancel setting the trace options and close the dialog? As I'm trying to show you the trace store, the thing I'm going to choose is to disable my address stops. So I'll click the top button. And you can see in the ribbon menu that the address stops is no longer highlighted and the trace store is highlighted. And that's because I've actually disabled the address stop. So a quick peek back at the thing, and you can see that all my address stops are disabled. Okay, so let's just run our test program again and see where we stop. Just give it a couple of seconds. Okay, so here we are stopped again, and let's go to the EBW area and have a look at the first byte, and we can see that we've got a value in there. So now let's step again, and it's updated. And now let's step again, and it's updated. And now let's step again, and it's updated. And now we've run to completion. So you can see there that we're watching that particular byte, and we're stopping when we see a change in that. So that's a very basic level trace store. The next thing that I'd like to show you is setting a compare value. So let's go back to our trace store in the dialog, and to set a compare value, we're checking this use compare data checkbox. This opens up an entry field where we can enter a value that we want to compare. What we're doing here is when we're watching the bytes that we say we want to watch, we're not just watching it for has it changed, we're watching it to say, does it match what the value that I'm entering here. So to show this, I'm actually going to increase the watch length to 8. And what you see immediately is that our area for entering compare data automatically updates depending on the watch length. So whatever I set my watch length to, that's how much I can enter as the compare data. And you can also see that we have one side which is hex, and the other side which is the actual characters. So you can enter either, you can enter hex or you can enter characters. I happen to have some actual alphabetical characters which I want to use for this particular demo. So I'm just going to enter the values there. It's A, B, C, D, E, F, G, H. Quite simple. So now what we should be doing is we should be looking at starting from the first byte of the EBW area and looking at the next 8 bytes to see if they match A, B, C, D, E, F, G, H. So I'll click OK, and I'll run my test program again. And it's we just wait until it's captured the ECB. Okay, so we've got the ECB, and let's go to the EBW area. And just looking at those first 8 bytes, you can see that we've stopped because it's A, B, C, D, E, F, G, H. Okay, I'll just step, and that should run to completion yet again. And the last aspect that I want to show you is how to set a mask on this. So if we open it up again, and if I click the use mask button, this actually opens up a whole other entry area where we can enter a mask. And what we do here is that we take the mask, and with the mask what you can do is you can set, you can turn on bits that you want to watch, and we'll actually watch for those particular bits and match it with the compare data. So to show this, I'm picking a very simple example so that it's easy to see. So I'm just going to set the watch length back to just 1 byte, and I'm going to look for the number 2. In fact, for you to be able to see it, let's start off without a mask. I'll show you what happens without a mask, and then we can compare it directly with what happens with the mask when we're searching for number 2. I think you can pretty much predict this, but just to demo it, I'm going to run my program. And what we're expecting here is we're expecting that if the first byte of the EBW area is equal to 2, we stop, but then we shouldn't stop on any other condition. So you can see that it's 2, and if I step again, it will probably run to completion because we're only stopping if that's equal to 2. So to take that same simple example again and add a mask to it, I'll just pop the mask here, and I'm going to add a mask of 0.3. So So what we'll be doing is we'll be using the mask against the value and then seeing if it's 02, and we'll stop if it is. And that will have the effect of saying stop if the second bit is on. So I'll just click OK for that, and I will run my program yet again. And let's have another look at the EBW area. So you can see that we've stopped because the value is 02, just like before, because that second bit is turned on. Let's step. And you can see that we have actually also stopped at E2, because now we're not just looking at what is the value of that byte, we're looking at what is the value of that specific bit, or those specific bits, and does it match our compare value that we're looking for. So if I step again, I think I should run to completion. Okay, so that's what I was intending to demo today. Just to summarize, what I've shown you is how to specify particular addresses that you want to stop at in the address stop. And you can do up to 8 of those. You can define up to 8. And I've also shown you how you can actually set it up to stop at specific data areas, and particularly you can stop when your specified data area that you're watching matches a particular value, or even when specific bits are matched. And that's all for this demo. So I'll hand back to Chitra.
Thanks, Vaila. That was an informative session. The session is open for your questions. You can either click on the hand raise symbol, or you can send a chat message to the organizer so that I can bring up your questions and get it clarified with the presenter and the technical experts in the call. The session is open for questions.
I see another question from Chitra. That is...
that's from Geeta.
Oh, that's from... Okay, Geeta. Yeah, this is actually the program flow. When you are right now, we're just showing like trace, store, and address stop. If you want to know the trace flow, then there is option in the trace. You can set all your options, like if you want to trace all the enter back, then you need to set up all the macros like enter back, and then you need to click the run on. Once you click on the run on and give your entry, it automatically logs into the trace output viewer. The trace output viewer there in the analyze tab. Maybe if you want, Viola, can you please give a sample entry? Just give a ZDSys and set up a trace flow for enter back macros.
Sorry, can you tell me again what exactly you want me to do? You want me to set?
Yeah, actually, Geeta wanted to know the trace flow, trace output viewer, how it works. So can you please just give an entry like ZDSys?
Just set all macros and ZDSys. Okay, let me just get rid of my trace.
Maybe selected macros as enter back, not all the macros. That would be easy.
Okay, I see. Okay, so just the enter. Okay, and then just do a ZDSys on that.
Yes, and just click on the run on so that.
Oh, okay, yeah. So I see, because we're just selecting the. Okay, I'll click on run on.
Okay, yeah.
And I'll do ZDSys.
Now she.
And then you.
Yeah.
So you want the trace output viewer, is that right?
Yes, right. Just open the trace output.
So this is macros. We didn't stop at any instructions.
Yeah.
Stores.
Yeah, the stuff. If there is any other stuff that will be displayed, and program flow. Just go to the program flow, and here you'll be able to see what is the program flow, what are the programs it traversed. So in that way, you can do the program flow trace.
Yeah.
Okay, so whenever you are trying to give a new entry, actually another question from Geeta, she just tried the same entry, but the outputs are appended. So what you can do is there is a clear button. So whenever you want the trace flow, then you need to clear the previous entries, and then you can start the new entry, so that the previous entries will be cleared and the new program flow will be saved here in the trace output viewer.
Yeah, so it's this button I'm pointing to now.
Geeta,
right.
does that answer your query? You're unmuted.
Yes. Yeah, thank you. Thank you. Actually, so clearing the old dumps is one of the mandatory procedure you are saying, Karthik?
It's not actually mandatory. Few things. If you want to compare two of the entries, it's better advisable to we are advising to clear the previous flow, so that will be easy. By default we are clearing, but sometimes we are advising you to clear. That's a better for the better output.
Okay. All right. I'll give it a try once again. By clearing and see. We'll check if it works.
Okay,
Fine.
sure.
Thank you for addressing the question. Thank you.
Sure.
Sharat,
The question is popping from
Sharat Yadav.
Yes, Sharat Yadav. He just asked, like, what is the benefit of address stop option when we already have options to run to cursor and skip to cursor. And one thing is, when run to cursor and skip to cursor, that will be done during the source view trace. So in this case, you don't have to bring your programs into source view. You can just stop at the graphical ECB and check your values. If you are fine with the values, then you can continue to the next ECB or next programs. So to run to cursor and skip to cursor only used in during the source view trace. You don't have to bring all the programs into source view trace just because want to verify some values. So does it answer your question?
Sharat, does that answer your question?
Okay. I've got a question on the registers. Has any consideration been given to be able to stop on a value that is a displacement off the registers? Because sometimes when we're in a loop, we bump the register. We want to stop at a certain value, say displacement of 20 off that register.
Yeah, I understand that. That is exactly like a core address. You can get the address and add the displacement and set as a core address value. So you don't have to rely on the register.
But if you're bumping through like DF records and you're in a loop and say register 7 is always pointing at the record and you're looking at a field that is displacement, say 10 off that record, you don't have the core address or the file address as far as that.
Okay. Yeah.
You just have the register displacement.
Okay, yeah, I understand that. For now, we don't have that option. We can take this as a suggestion. We'll do it on that in our future enhancements.
Okay. It'd be a nice to have.
Yeah, sure, Mike. I understand. Yeah, thank you.
Thanks, Lore. You're now unmuted. Can you ask a question to the presenter and the Karthik in the call, please?
Sure. I have a question regarding the address stop. So once it stops at the that displacement, can we just step to the next instruction, or we will have to bring in the source and continue tracing from there?
You can do either way. There is an option to go to the next instruction or next address stop in the ECB window itself. You can go in that way, or else if you want to go do a source view, then you can bring the program into source view. We already have an option to do go to a next instruction without bring the program into source view. I guess maybe you just stop a program. Viola, can you please stop a program in a graphical view so that I can show her?
Yeah, sure. Let me just go to the trace. So you're talking about
instruction next to instruction.
Oh, I see. Okay, yeah. Okay, sure. I'll just run what I've already got here. Let me run off.
Yeah.
And then, yeah, and then you just want me to step by instruction as what?
Yes, right. Yes.
Yeah, sure.
That is instruction step.
Yeah. So this is the instruction step. So if I just do this, I step by instruction.
Yes. You can do it without bring the program into source view. If you want, you can also bring the program into source view. That's based on the user requirements.
Oh, okay, sure. Okay, thank you.
Okay, we don't see any further questions with this. We come to the end of the session. Thank you all for joining the session.
Thank you, everyone.
Thank you.